Hello students, welcome to Anne's classes. Let's do area of a trapezium and a polygon, exercise 22C. Question 1, multiple choice type. Choose the correct answer from the options given below. The parallel sides of a trapezium are 12 centimeters and 10 centimeters. If the distance between the parallel sides is 10 centimeters, we have to find the area of the trapezium. Now, what is a trapezium? A trapezium is this figure. This is a quadrilateral. Now, a trapezium has one pair of parallel sides. So, here you can see one side 12 centimeters and this is 10 centimeters. We can name that. So, we can name this as AB and CD. So, AB and CD are the two parallel sides. So, one pair is parallel as you can see, whereas the other sides are not parallel. So, this is a trapezium. And we've been given the measurements of the sides AB and CD, the two parallel sides. Now here it says if the distance between the parallel sides is 10 centimeters, so DE, we can name this as DE. This is the distance between the parallel sides and that is 10 centimeters. Now we should remember this, that is the height of a trapezium. What is the height of a trapezium? It's not given to us, but the distance between the parallel sides is the height of the trapezium. So DE is the height of the trapezium. So we've been asked to find the area and the formula is half into sum of the parallel sides into the height. So let's do that. So we can say half is 1 by 2 into parallel sides. What are the two parallel sides? 12 centimeters and 10 centimeters. So sum means we have to add it up. So add up these two and multiply this by the height, and the height is also given to us as 10 centimeters. So let's simplify this. 1 by 2 into 12 plus 10 is 22 into 10. Now we can cancel here itself. So I can cancel this. 2 ones are 2 and 2 into 11 is 22. Now we can simply multiply. So here 11 into 10 is 110 and the units are centimeters. So because it's area, it is centimeters square. So we have found the area of this trapezium, that is 110 centimeters square, and that is option B, 110 centimeters square. Question 2. Two parallel sides of a trapezium are in the ratio of 2:3. So now we are not given the actual measurement, we are only given the ratio of the two parallel sides. And the distance between them is 12 centimeters. If the area of the trapezium is 240 centimeters, what is the length of the larger parallel side? So as we know, this is a trapezium. It is a quadrilateral in which one pair of sides will be parallel. So here they are saying the two parallel sides are in the ratio 2:3. So we can write this as 2x is to 3x. And the distance between them is 12 centimeters. Remember, we said the distance will be the height and the parallel sides can be taken as the base. Now here the area is given to us. So now we just have to find the length of the larger side or larger parallel side. Okay, so first we need to find the value of x. So we're going to say let the two parallel sides be 2x and 3x centimeters. The height is given to us as 12 centimeters and the area is also given to us as 240 centimeters square. Now what is the formula for area? The formula for area is half into sum of parallel sides into height, and area is already given to us. Let us substitute wherever we can. So 240 is equal to 1 by 2 into sum of the parallel sides. We said the parallel sides will be 2x centimeters and 3x. So we will add this up. 2x plus 3x into the height, which is 12 centimeters given to us. Now let's simplify. 240 equals 1 by 2 into 2x plus 3x is 5x into 12 centimeters. Now cancel, 2 6's are 12. Now what do we have? We have 240 equals, now let's multiply here 5 into 6. 5 6's are 30, 30x. Now we can find the value of x. X is equal to 240 divided by 30. First we can cancel the zeros, then 24 and 3. 3 8's are 24. So now we have found the value of x. X is equal to 8. Now, what does the question ask us to find? We have to find the length of the larger parallel sides. So here we said let the two parallel sides be 2x and 3x. 2x is a smaller one and 3x is a larger one. So this is what we need to find. So 3x is what we need to find, and we know the value of x. X is 8. So the larger side, we can say the larger side is 3x, which is 3 into x. 3 into x is 3 into 8, which is 24 centimeters. So this is our answer. The length of the largest side is 24 centimeters, and that is option C, 24 centimeters. Question 3. The adjacent sides of a parallelogram are 12 centimeters and 9 centimeters. Here we are talking about adjacent sides. The distance between the longer sides is 6 centimeters. We have to find the distance between the shorter sides. Now, what is a parallelogram? Now, that is also a quadrilateral. Here, both the sides, it has two pairs of parallel sides. That is, if you look at this, this is a parallelogram. You can see AB and CD are parallel. Similarly, AD and CB are parallel. So that means this is a quadrilateral in which it has two pairs of parallel sides. And the opposite sides are equal in length. Now, if this is 12 centimeters, CD is also 12. If BC is 9, AD is also 9. And here it says adjacent sides. That's how we got these. AB and BC are called the adjacent sides. So this is 12 centimeters, this is 9 centimeters. The distance between the longer sides. Now, these are the two longer sides. The distance will be like this. What we get is the distance, DE. And that becomes the height. And that is 6 centimeters given to us in the question. Now, we have to find the distance between the shorter sides. So, these two, that is AD and BC are the shorter sides. The distance will be this. D, we can mark this as F. So, DF is the distance between the shorter sides. Okay, it forms 90 degrees, remember. So they form 90 degrees there. So this is what we need to find. We need to find DE, the measurement of DE. So let's begin by saying area of the parallelogram is base into height. So here we can find the area first of this parallelogram with the base as AB and the height is DE. So once we find the area, we can use that same thing to find DF. Okay, so here area of the parallelogram, in this case, we're going to take the base as AB and the height as DE. That means base is 12 centimeters and DE, the height is 6 centimeters. So 12 6 are 72. So this is 72 centimeters square. So now that we have found the area of the parallelogram, we can again apply this formula and find the height, this time using BC as the base. So let's do that. So area of a parallelogram, we're going to use the same formula, base into height. This time the base is going to be BC and the height which we have to find is DF. Now BC is already given to us as 9 centimeters. We don't know DF and that is what we're going to find. But we also found out what the area is and that is 72 centimeters square. So now that we have this side and 9 centimeters here, we can find DF. So let's find DF by saying DF equals 72 centimeters square divided by 9. Okay, that is, how did I get that? The 72 is already there. 9, I've taken it away from DF, I've taken it to the other side. That's how it's become division. Now let's cancel. 9 ones are 9, 9 eights are 72. So now we have found DF, or the distance between the shorter sides. So DF is the distance between the shorter sides, and that is 8 centimeters. This is our answer, and that is option C, 8 centimeters. Question 4. Each side of a rhombus is 9 centimeters and the distance between its opposite sides is 6 centimeters. We have to find the area of the rhombus. Now, what is a rhombus? It is a parallelogram whose all sides are equal. So we have a rhombus here. All sides are equal. That means this side, all these will be 9 centimeters. 9 centimeters is given to us. and all sides will be 9 centimeters. Then we're also given the distance between its opposite sides. So these are the two opposite sides. The distance is the height, and that is 6 centimeters. Now we can find the bases. Take the base as 9 centimeters, the height as 6 centimeters. We can find the area of the rhombus by saying base into height. And base is 9 centimeters, height is 6 centimeters. 9 sixes are 54 centimeter square. So this is our answer, and that is option A, 54 centimeter square. Question 5. The diagonal of a rhombus is 15 centimeters and its area is 60 centimeters square. The other diagonal of the rhombus is what we need to find. So we have the figure here. We have the diagonal shown here, and this is one diagonal, and this measurement is given to us. Now we have to find the measure of the other diagonal. So the diagonal of the rhombus is that's given to us is 15 centimeters. Area of the rhombus is 60 centimeters square given to us. Now let the other diagonal be D. That means this diagonal, we'll call it D. So let this be D. Then, since area is given to us, we can use the formula of area to find the other diagonal. Now why are we using it? Because the formula says this. Area of a rhombus is half into product of its diagonals, both the diagonals. So from this we can get the measure of one diagonal. Area is given to us. Let's substitute. Area is 60 centimeters square. And this is equal to 1 by 2 into product of the diagonals. One diagonal is 15 centimeters. The other diagonal is D. So we're going to use this. So 60 on the side, half into 15 into D. So we're going to find the value of only D. So we're going to leave D here on the left hand side. On the right, we already have 60 in its place. And we are going to move this half to the other side. Because it's multiplication, when it goes to the other side, it becomes, it's division here. So it becomes 2 by 1 there, or 2 by 1 into, now 15 also we are transposing to the other side. Because it's multiplication, it becomes division. So we can put it straight under this itself as division. So we don't have to put another sign there. So here we have 60 by 15 into 2 by 1. Let's cancel. Now we can cancel these two. 15 ones and 15 fours are 60. Now multiply the numerators. 4 twos are 8. So we have found the measure of the other diagonal, and that is 8 centimeters, and that is option B. Option B, 8 centimeters. Question 2. The following figure shows the cross-section ABCD of a swimming pool, which is a trapezium in shape. So this is the cross-section of a swimming pool, ABCD, and this is trapezium in shape. If the width of the swimming pool is 6.4, this is the width, that is DC is 6.4 meters. So let's write that, 6.4 meters. This is the width of the pool. And here it says the depth AD. The depth AD means it's here. The depth at the shallow end. So AD at the shallow end is 80 centimeters. So let's convert this to meters. We know that 100 centimeters make a meter. So 80 centimeters will be 80 by 100. So here we can cancel the zeros, and 8 by 10 is going to be 0.8. 0.8 meters. So here at the shallow end, the depth is 0.8 meters. So we have this here. Then depth BC at the deepest end. That is, at the deepest end, BC is 2.4 meters. Let's write that, 2.4 meters. Now we have to find the area of the cross section. So area of the cross section is the area of this trapezium ABCD. So what is the formula to find the area of the trapezium? Half into sum of parallel sides into height. So let's substitute wherever we can. So that is 1 by 2 into sum of the parallel sides. So we have two parallel sides here, 0.8, the side AD and BC. These are parallel sides. So we can add up these two. So that will be 0.8 meters plus 2.4 meters into the height, and the height is the distance between the two parallel sides. These are two parallel sides. The distance is the height, and that is the width, which is 6.4 meters. So we can say 6.4 meters. Now we just have to simplify this. So first let's do the addition. 1 by 2 into, now let's add this up, 0.8 plus 2.4. 8 plus 4 is 12, carry 1 is 3, 3.2. So this is 3.2 into 6.4. So first let's cancel and see what we can. I can cancel this. So 2 into 1.6 makes it 3.2. Now we can multiply these two. So when we multiply, we get 10.24. So we have found the area of the cross section, and that is 10.24 square meters or meter square. So this is our final answer. Question 3. The parallel sides of a trapezium are in the ratio 3:4. If the distance between the parallel sides is 9 decimeter and its area is 126 decimeter square, find the lengths of its parallel sides. So decimeter is another unit of length. Okay, so now let's draw a figure to understand. So we have a trapezium, the parallel sides. So AD and BC are the two parallel sides. So we can draw the arrowheads for us to understand. These are the two parallel sides and they are in the ratio 3:4. So we can say let the two parallel sides be 3x decimeter and 4x decimeter. So this is 3x and this is 4x based on the ratio. Now the distance between the parallel sides is 9 decimeter. Distance is the same as height. So the distance between the two is 9 decimeters. So we are writing that as the height, and the area is also given to us as 126 decimeters square. Now we have to find the lengths of his parallel sides. Now we know it is 3x and 4x, but we have to find the actual length. So we have to find the value of x. Now we know the area, so we're going to use the formula for area to find x. So area is half into sum of the parallel sides into the height. So this is going to be half into sum of the parallel sides. So the first parallel side is 3x plus the other parallel side is 4x into the height, which is 9. So now area is also given to us, like I said, so that is 126. So now let's continue. 126 is equal to 1 by 2 into 3 plus 4 is 7. So that is 7x into 9. So here, since it's multiplication, we can multiply all the numerators. 1 into 7x into 9. So here it is 126. 1 into 7x is 7x. 7 nines are 63. So that is 63x by 2. So now if we continue, 126 is equal to, here let's write x. Since we are finding the value of x, let's write x here. Now on the other side we have 126, isn't it? We have 126 on the other side of x. Now here we have 63 by 2. 63 by 2 into x. So when it goes to the other side, it becomes division. So divided by 63 by 2. I'll continue it here. So here x is equal to 126 into 2 by 63. Now we can cancel 63 and 126. 63 into 2 is 126. So this is 1 and this is 2. So now 2 2s are 4. So now we have found the value of x. X is equal to 4. Now we have to find the two parallel sides. In the beginning we said let the two parallel sides be 3x and 4x, isn't it? So we can find the parallel sides. So 3x is equal to 3 into x, that is 3 into 4. 3 fours are 12. So this is one parallel side, 12 decimeter. The other one is 4x, which is 4 into 4. 4 fours are 16, 16 decimeter. So we have found the two parallel sides. One is 12 decimeter and the other is 16 decimeter. Question 3. The two parallel sides and the distance between them are in the ratio 3:4:2. If the area of a trapezium is 175 centimeters square, find its height. So here we are talking about a trapezium, and here 3:4 is the two parallel sides ratio and 2 is the distance. So the two parallel sides and the distance between the two parallel sides are in this ratio. So let's consider the two parallel sides to be the first two, that is 3x and 4x centimeters, and the height, let it be 2x centimeters. Remember, distance is the same as height. Now we've been given the area, which is 175 centimeter square. Let's use the formula and find the height. So the formula is this. So area is given, let's substitute 175 centimeters square, half into sum of the parallel sides. So parallel sides we said 3x and the other one is 4x. So the sum is 3x plus 4x into the height, which is 2x. So here we can cancel. I can cancel this 2 and this 2. So now let's continue. 175 is equal to 3x plus 4x is 7x into x. Remember, here we've only cancelled the number. X is still there, so that x I've written it here. So now this will be 175 is equal to 7x square. So 175 is equal to 7x square. Now we are going to find the value of only x square. So x square will be equal to 175 divided by 7. So let's cancel. 7 ones are 7. 7 twos are 14. Now there is 3 left, so 35. 7 fives are 35. So if x square is 25, x will be the square root of 25. And what is the square root of 25? 5, because 5 into 5 is 25. So x is equal to 5. So we have found the value of x, but what have we been asked to find in the question? In the question, we've been asked to find the height. So here we said height is 2x centimeters. So let's write that. So is 2x centimeters. So now we know the value of x. We can substitute 2 into x and x is 5. 2 into 5 centimeters. 2 fives are 10, so 10 centimeters. So we have found the height. We've been asked to find the height. We have found the height to be 10 centimeters, and that is our answer. Question 5. The adjacent sides of a parallelogram are 21 centimeters and 28 centimeters. If one diagonal is 35 centimeters, find the area of the parallelogram. So we'll draw a parallelogram here. The adjacent sides are 21 centimeters. So 21 centimeters and 28 adjacent sides, not the parallel sides. And one diagonal is 35 centimeters. So now we know, since this is a parallelogram, if this is 21, this side is also 21. If this is 28, the opposite parallel side is also 28. So let's write what's given to us. The adjacent sides are given 21 centimeters and 28 centimeters. We've also been given one diagonal, and that is 35 centimeters. Now we have been asked to find the area of this parallelogram. To find the area of this parallelogram, we need to know the base and the height. The base is there, but we don't have the height. So what is the other way of finding it out? The other way is we can consider this diagonal to have divided this parallelogram into two triangles, and both are equal triangles. So if we find the area of this triangle and this triangle and we add it up, we get the area of the parallelogram. So since three sides are given, we can find the area of this triangle using the formula. So here area of the parallelogram will be 2 into area of angle ABD. So ABD is one triangle. If you find this area and you multiply it by 2, you get this triangle also. So when you multiply it by 2, you get the area of the parallelogram. That means we have to find the area of triangle ABD. So for that, we need to consider the sides here. We can consider this as side A, side B, and side C. So let's write that. So A will be 21 centimeters. B is 28 centimeters and C is 35 centimeters. So now that we use this, we know the sides, we can find the semi-perimeter. How do we do that? A plus B plus C divided by 2. So that will be A is 21 centimeters, B is 28 and C is 35. We have to add all that up and divide it by 2. So when you add all this, you get 84. Divide 84 by 2. 84 divided by 2 is 42. So we have got the semi-perimeter, that is 42 centimeters. Now we can find the area of angle ABC by using this formula. So that is semi-perimeter, which is 42 into 42 minus side A, which is 21 centimeters, Again 42 minus side B, which is 28 centimeters. Again 42 minus side C, which is 35 centimeters. So we have to work this out now. So 42 into 42 minus 21 is 21, into 42 minus 28 is 14, into 42 minus 35 is 7. So there are two ways of doing it. One, you can multiply all these, get a number and find the square root. Or let's see if we can split these into numbers that are already here. So here 42, let's look at 42. We can write that as 21 into 2, isn't it? So let's write that. So 21 into 2 or 2 into 21 is 42. So we've got this number. Now this is already there, so we can just write into 21. Now let's look at 14. We can change that also. We can write 2 into 7, isn't it? So 2 into 7, and then we have this 7 here, so into 7. So this is another way of doing it. Now we pair up. Now here we have two 21s. So I can write 121 when I'm taking the square root. Then I have two 2's. I have 1 2 here and 1 2 here. I can take just 1 2, and I have two 7's here. I can take 1 7 from that into 7. Now when I multiply this, I get 294. Now this is the area of triangle ABD. Triangle ABD, the area is 294 centimeter square. So let's go back to the figure. So we have found ABD, the area, this is 294. So if this is 294, this will also be 294. So we can add up both 294 plus 294, we get the area of this parallelogram, or we simply multiply 294 into 2. So the area of the parallelogram is 2 into the area of triangle ABD, which is 2 into 294. Now, how much is that? That will be equal to 588 centimeters square. So we have found the area of the parallelogram, and that is 588 centimeters square. We will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you.